The producers and distributors of Tech AV Technical Audiovisual Learning Aids welcome you to program number 2 in the Brazing and Braze Welding series. In this program we will explain and demonstrate brazing and braze welding procedures on typical workpieces. Let us begin with brazing using silver-based alloys. There are essentially 6 steps to take in any brazing procedure, namely, ensuring correct fit and tolerances, cleaning of metal surfaces, selection of filler and flux, set up parts for brazing, the brazing process, and removal of residual flux and oxides. We will overview each step individually. Brazing, as we learnt in the previous program, is dependent upon a close fit and capillary action to draw the molten filler alloy between the adjoining surfaces of the base metals. The ideal clearance for maximum strength in a brazed joint is 0,15 millimeters, and naturally this precision is not always possible or practical to maintain. For most practical applications involving the joining of flat surfaces, we need only make sure that surfaces to be joined are perfectly flat, clean, and slightly roughened in order to achieve adequate capillary action. Where parts made of the same material have to fit into one another, then a slip fit at room temperature will provide the correct gap for capillary action. However, when joining dissimilar metals, we must allow for the different expansion rates of the dissimilar metals when heated. For example, copper and brass expand at a greater rate than steel. If we intend to fit and braze brass into steel, we must ensure that, prior to applying heat, there is sufficient clearance to allow for the greater expansion of the brass. Upon heating, the clearance will decrease sufficiently to allow capillary action to take place. Obviously, if we intend to fit steel into copper or brass, then a tight or press fit must be provided at room temperature to ensure the correct clearance at brazing temperature. A consideration regarding the assembled strength of tubes is that the inner section be inserted into the outer for at least the equivalent of the tube diameter. Some fittings, such as this pipe connector, may have insertion marks. Make sure that the inner tube is inserted to this mark before brazing the joint. Step 2. Cleaning. Metal surfaces must first be degreased using a commercial solvent or degreasing agent. In this experiment, we have deliberately included some grease upon the metal, and as can be seen, fluid will not flow in these areas, and this would seriously weaken a joint. Metal oxides, such as rust in the case of mild steel, should be removed by sanding or even machining where necessary. Non-ferrous metals like copper and brass rarely need heavy sanding or grinding. Mechanical cleaning of copper and brass is most usually effected using a scouring pad. After grinding or scouring, further cleaning with a degreasing agent will be necessary to remove loose particles. In some situations, scale and oxides may be removed or loosened chemically in an acid solution. This is known as pickling. Naturally, extreme care must be taken should you work with acid or other corrosive products. The parts, after pickling, must be thoroughly rinsed in fresh water and dried. Any excess oxides or residue can now be easily removed by light scouring.